Okay, so yesterday we saw how we can split along the vertically, or split horizontally. Your data bar, right? So there's an easier way than this. Split existing on that. Right? There's an easier way, which is np dot v split edge split. Right? So you can use edge split. When we're trying to split horizontally. I know horizontal split got lag. So let's try that. Hey, let's try this. So if I do grid, grid, right, rather np dot horizontal split, okay, let's split, okay. And the of course I need to give the grid, comma, and then I can give this 256 needle. Yeah, okay. So you got it. Now I don't have to give the axis. See, I get the same result without giving the axis. Right? And it's more intuitive, right? Horizontal. Right? As soon as the headwind tech, okay, it's horizontal. Right? Axis equal to 1, right? Now you have to think more. Right? Well, you could have put right? Okay, so likewise, you can do same thing with vertical split, a vertical split in area. No? So if I do, okay, let's change the grid to something else, -1. So minus 1. Okay. So this is grid. So grid. Okay, so if I do a vertical split, right? That is given np.v split. Okay? np.v split, and then I need to do the grid. Right? Grid, comma, and then let's see. And then you guys already know. Okay? I can do here also 256. So okay, so we get vertical split. Okay. So V split and S split, they make our job easier. Stay, you okay, this right? So okay. Okay, so yes, some key questions. We did that side. All right, so now you guys know that now. So of course we can do you just split governments, and then you can put them in different variables. What are split nonsense? This is now 1, 2, 3, 4. It's already split and it's something like x1, x2, x3, and x4. So isma we got x1, x2, and so on. Unpack yes, the unpack eligible result into list of arrays also, and this was the unpack by that. First rating x1 was second rating x2 was and so on. Okay, so again, and then you can do the process for the last one. Okay, so these are all things it's okay. All right, so far I got these parts. Okay, the next topic is computation on Empiri's universal functions. Universal functions. Okay, universal functions. The region NumPy is so important in the world of Python data science that it provides an easy and flexible interface to optimize computation with a range of data. Right? So your sentence, the keyword is optimized. Right? This is the key. Right? So optimized computation on other, I would say, bigger range of data. Right? Bigger range of data. That's where it shines. That's where NumPy shines. Right? Okay. What makes them so fast? What makes them so fast? On the vectorized operation, right? On vectorized operation, right? You'll see what they are, right? Which is generally implemented through NumPy's universal functions. So also, in short, they're called UFuncs, right? Universal functions. Okay. Now, okay. Okay, so let's look at this example now. This new example. So simple, very simple example. So you rather what I'll do is this. I'll just copy this. I'll just copy this. So it's my case here. So, so I need to fix this. So let's see. So, let's see, it's a return. This is the return out. Right. So let's see. Okay, here's a function, right? A normal function. Okay, can you guess what it does? Your function if you want to. Okay, what it does is it takes some kind of a list or array, right? Some kind of collect. Right? So त्यो लिन्छ अनि त्यसले के गर्छ भने त्यही बराबरको एउटा आउटपुट भन्ने एउटा त्यो बराबर के है जस्तै मैले यहाँ 5 वटा एलिमेन्ट एउटा array दिएँ भने यसले एउटा आउटपुट भन्ने एउटा नयाँ एम्प्टी array बनाउँछ है जसमा कि हाम्रो भ्यालु इनिसियलाइज गरेर हुँदैन त्यो लेन भ्यालु चाहिँ कि त्यसको जति लेन्थ छ त्यही बराबरको एउटा आउटपुट छ अनि के गर्छ भने फर I in range लेन भ्यालुज अब यसमा इटरेट गर्छ यो एरेमा इटरेट गरेर के गर्छ भन्दाखेरि अब आउटपुटको जस्तै आउटपुटमा के राख्छ भन्दाखेरि त्यसको करेस्पोन्डिङली त्यसको फर्स्ट एलिमेन्टको रेसिप्रोकल अनि सेकेन्ड एलिमेन्टको रेसिप्रोकल अनि थर्ड एलिमेन्टको रेसिप्रोकल एन्ड सो अन अनि त्यो आउटपुटलाई चाहिँ रिटर्न गरिदिन्छ है सो लेट मी quickly you can understand this based on what we have done so far. It's a very simple function. It's still right. Let me just quickly show you anyway. Right? It's like you want to right? We pass some kind of some array or list or whatever. Right? Array. So yeah, then I'm doing array pass. I pass this. It's the 1, 5, -2, 3. And you say values. You see my pass values array, right? And here output is equal to np.empty len values. This could len your values could len
5, 4.
You can charge it into 1, 2, 3. अनि यसले के गर्छ np.empty चारवटा हैन चारवटा सेम है चारवटा एलिमेन्ट अट्ने गरी उले चाहिँ एउटा हैन अर्को के गर्यो यसले भने एरे बनायो हैन अर्को एरे बनायो np.empty यो चारवटा एलिमेन्ट एम्प्टी एरे बनायो त्यसमा चाहिँ हामी थप्छौँ So and this is here for I in range len values. Right? When we say अब यसले अब I ले iterate गर्छ फर्स्टमा I को भ्यालु 0 हुन्छ I को भ्यालु सुरुमा 0 हुन्छ हैन 0 हुन्छ अनि त्यसपछि के भयो भने आउटपुट I है index 0 index 1 index 2 index 3 right so output I यो चाहिँ आउटपुट है by the way this is the output I equal to के भयो 1 divided by the value of I value I. And you see 1 divided by q, 1 divided by value is IQ, value 0 q.
1 divided by 1.
Hey, this thing our next iteration IQ value 1 by right? Our say q. So 1 divided by 1.0 divided by 5. Right? This thing very 1.0 divided by -2.
-2.
And this will say 1.0 divided by 3. है बुझ्नुभयो सबै त्यसरी गर्छ अनि यसैलाई रिटर्न गरिदिन्छ यसलाई रिटर्न गर्छ है भनेपछि तपाईँको के आयो भन्दाखेरि यहाँनिर चाहिँ के दियो हामीले कुनै एउटा एरे दियौँ भने त्यो एरेको हरेक एलिमेन्टको के दियो यसले के दिन्छ रेसिप्रोकल दिन्छ है रेसिप्रोकल मिन्स one divided by that same number है जस्तै 3 को रेसिप्रोकल 1/3 है ठिक छ यहाँसम्म बुझ्नु भएको छ ठिक छ बुझिरहनु भएको छ है एनी क्वेसन
No, sir.
Okay. Over you one. See now let's do some let's compute some reciprocal. With that. So for example, yeah, I can use this one. Values, yeah, I think I have this. Where's the values? Yeah, I can copy this. So I want to make a reciprocal. I want to get the reciprocal of each of these items. Right? So what do I do? Compute reciprocal, and I just pass the values. Right? See, yes, so reciprocal 1 divided by 1, 1 divided by 3, 0.33, 1 divided by 6, 1 divided by 8, and 1 divided by 8. Right? Okay. So it's a reciprocal. I know. Okay, the magic of okay, the UFOX, you'll see in a moment. Right? What if this one was 1, 2, 3, 4, 5 element? What if I have 1 million or maybe 10 million right? Elements? Right? This is my unit. Let's see. This is my Python is we have a magic function. Right? So magic function is your percent time it the magic function. So it runs that operation on the time it operation. Let's say it runs over and over. Right? Run this average. Right? The average is the best. Right? Best timing. Something compensate timing. Best. This is really best of 5. So okay. So it is a run. So it is let's say best of 5. 5 run best timing. Let's say the operation execute like time right? Your time is again. Okay, so let's see. Let's okay. Okay, so we'll time it. Right? So we just create a big array with 1 million elements. A big array. Okay, so big array called integer random variant 0 to 99. 0 to sorry, 1 start and 100 something. 1 to 99 which any random number. Any side check at 1 million. 1 पछि 6 0 1 million. 10 lakh. 10 lakh. Okay. We have 1 million array. So it's that big array. With big array with my shape here, it's really big. Okay. Not shape. 1 million. 1 million elements. Right? So, okay, let's compute the reciprocal of this 1 million elements using this function. Hey, using let's time it when you hey, so time it, hey, time it. Right? And it is compute reciprocals. And this is a bigger rate. Okay, takes it. Time it, compute reciprocals, bigger rate. Right? Let's see. Let's take nearly there is read on this. So, so here, okay. several one loop each. Okay, so when it was equal to 3.73 seconds plus minus 70.2 milliseconds. Okay, it is 3.73 seconds live. Okay, okay. So average 3.73 seconds live. Equal. Okay, you say with second live. You say second is an eternity. Right? Computer like second the eternity. Only long time. Right? Very time. 3.73 1 million array lie. 1 million element per array lie. So your reciprocal income like very time lie. Right? 3.73 seconds. Very time lie. Okay, so can we do and can we improve? Can we improve on this? Yes. Right. So as you can see, is it 2.37 seconds? So as you can see, the implementation of computing reciprocals by using loops is extremely slow, a few seconds per loop. So now let's implement the same operation as above using the vectorize operation. I would say you say loop operation. Loop is always slow. Either loop is slow. Okay. Let's use our SLI. We use vectorized operations. Right? Vectorized operation. Vectorized operation now same thing. Right? Same thing. We do percent time it, and this was simply 1 divided by big array. Simply right? 1 divided by big array. Right? That's it. Let's see. Kati layo? Time kati layo? 5.61 milliseconds. Right? 5.61. Agi kati thiyo? Yeah, understand? Agi kati thiyo? 3.73 seconds. You see? Milliseconds. भनेपछि कति फरक भयो? कति मिलिसेकेन्डको एक सेकेन्डमा कति मिलिसेकेन्ड हुन्छ? 1000 हैन? Okay, 10 to the power -3 is milli हैन? Milli भनेको 10 to the power -3 हो नि त. है? Micro भनेको 10 to the -6 हैन? Nano भनेको 10 to the power -9 हैन? And so on. Pico 10 to the -12. Is that right? Okay. And so on. Okay, so when you see 10 to the -3, when you say that, micro, kati times? Kari 1000 times faster. Hey, you understand? This does the same thing, exact same thing. This also does the same thing, but about 1000 times faster. You see, milliseconds per second. Okay. All right? Okay. And the orco correct you now you don't have to write all those reciprocal function theory. You have to run a loop and everything. You don't have to do all those. It's simply given 1 divided by big array. That's it. Understand? What is सजिलो तपाईले यो कम्प्युटर स्कुल गर्दाखेरि 6-7 लाइनको कोड लेखेर त्यसमा तिमीलाई हैन त्यो झन्झट थियो नि अब यसो के पनि गर्नु पर्दैन 1 divided by big array सिधै हैन so यो expression पनि कति simple छ plus the external so यसलाई this is vectorized operation just like we don't use any loops okay so vectorize vectorize means we just say सबै मैले अघि भनेको थिएँ optimize is the keyword. Right? So because these are all optimized, right? Optimized feature, these are performed through UFUNCs, universal functions. Universal functions this is implemented very well. And they are highly optimized. Right? Highly optimized. Right? Okay. So they're extremely fast. Okay? So vectorized. So मैले तपाईलाई homework दिएको छु हैन यो homework है तपाईको जस्तै numpy exerciseहरु छ त्यसमा चाहिँ you need to use vectorized operator. You're not allowed or supposed to use loops. Right? Loops are used on Python. This one do not use loops. Right? Loops are a no-no. Your numpy word my loops are a no-no, absolute no. Okay. you need to use vectorized operations. Okay, so you think this is a vectorized operation. So first thing, super fast, blazingly fast, and then also very simple expressions, simple, intuitive, extremely simple operations. Vectorized operations. Okay. All right. So any questions so far? Okay, then let's move on. Okay, यो पनि भयो
असाइनमेन्ट बारेमा त्यो नम्पाईको असाइनमेन्टमा त्यो सुरुमै फर्स्ट ब्लकमै एरर आइरहेको छ के त्यो टगल वाला त्यो कोडले
ओके
अनि त्यो कोड चाहिँ एडिट नगर्ने भन्नुभएको थियो मैले चाहिँ लाइक कमेन्ट आउट गरेर गरिदिरहेको छु
एरर आयो भनेपछि तपाईको टेस्टमा एरर आएको होला टेस्टमा एरर आयो भने तपाईको कोड मिलेन त्यो चाहिँ टेस्टिङ कोड
हैन त्यो हैन फर्स्ट नै जुन त्यो x र y को भेरिएबल जुन फर्स्ट क्वेशनमा के छ भने चाहिँ 0 चाहिँ एरेमा छ एकचोटी हेर्नु न
so let me check it because you really very group like this again nobody so यसमा तपाईले भन्नुमा चाहिँ यो यसमा एरर आउँछ भन्नु हो यो रन गर्दाखेरि क्वेशन नम्बर 1 भन्नु हैन कसले सोध्नु भएको थियो कसले सोध्नु भयो
ए मैले सर त्यो हजुरले पठाएकोमा चाहिँ जुन यो टाइटलको माथि चाहिँ हैन तीनटा ब्याकटिक अनि त्यसपछि कर्ली ब्र्याकेट भित्र चाहिँ टगल थियो अनि फेरि लास्टमा चाहिँ तीनटा ब्याकटिक थियो के अनि त्यसले गर्दाखेरि चाहिँ एरर सिन्ट्याक्स एरर भन्न आइरहेको थियो
देखो म यसैबाट अनि त्यस्तो त्यो कि तपाईले यसो गर्नुस् त्यो फेरि त्यो मैले तपाईलाई पठाएकैबाट खोल्छु है त Okay, so Python training for students. Assignments. Yeah. Okay. So right here, right? Okay. So rather, it's like triangles. Okay, let's see while it's loading. Check what the answer does. Your phone scenario. Okay. All right. Okay. Yeah, that. मैले भर्खर लोड गरिसकेँ सो ओके ओके सो मेबी आई मिस्ड सायद केही चेन्ज गर्दाखेरि यहाँ ओके ओके अरूमा त प्रब्लम छैन नि
अरूमा चाहिँ छैन अनि त्यसमा चाहिँ म त्यसमा चाहिँ त्यो माथिको लाइन र लास्टको लागि चाहिँ कमेन्ट आउट गर्दिए अनि
ए ओके त्यसपछि चाहिँ चल्यो हैन यहाँनिर I don't know how you covered that. I mean, you last time some because अर्को ग्रुपलाई इभिनिङ ग्रुप छ उहाँहरूले बुझाइसक्नु भएको छ they didn't have any problems कति बेला यहाँ इन्ट्रोड्युस भएछ so I'll fix this and मैले जस्तै अब यहाँ एकैछिन यो गरेर I'll send it
अझै एउटा है सर अझै एउटा क्वेशन छ जुन त्यो तल क्वेसन नम्बर चाहिँ मैले तलबाट एउटा त्यो आरएनजी त्यो डिफल्ट आरएनजी गरेर र्यान्डम वाला खोज्छु
Yes, question for you.
यो डिफल्ट आरएनजी हैन ल ठीक छ नि यहाँसम्म चाहिँ ठीक छ है सर अनि त्यसपछि तल अर्को क्वेसन लेख्नु
And यसमा के question दिएको हैन
नर्मल
okay यो वाला यसमा के question तपाईं question बुझिन मैले
एउटा क्वेसन थियो मैले बिर्सेर
ओके ठिक छ त्यो पछि डिस्कस गरौँ हैन सो यसो भनौँ न म यो तपाईको हाम्रो नम्पाई सिट दिने बित्तिकै म तपाईहरुलाई यो यसै पनि I will brief you है I'll brief you on this है सो त्यतिबेला this specific question छ भने पछि okay so let's get back to our lesson okay so यहाँनिर अब यो okay so let's do so vectorized operations are in NumPy are implemented using ufuncs okay? Ufuncs can be unary or binary okay? So let's see. Below you can see some examples of ufuncs okay so just say we have this all right so x right x new रहेछ यसमा understand quite simple छ है अब we're doing ufuncs universal functions universal functions okay अब यसमा जस्तै मैले if I do x plus 3 गरे understand मलाई सबैमा element wise so 3 जोडेर आउँछ 0 plus 3 is 3 1 plus 3 is 4 2 plus 3 is 5 and so on right likewise कुनै पनि arithmetic operation हैन times है गर्दाखेरि understand 0 so हरेकमा 3 ले multiply भएर आयो because it's simple understand so I can do anything like minus okay? minus 3 minus 2 minus 1 and 0 right? Okay or I can do divide understand see so these are all vectorized and they're implemented through something called universal functions right? I can do all of those like for example this floor division right? And likewise see very simple right? okay so this thing we have something stable so you सबैलाई म negative बनाउनु पर्यो x x I want to make all of them negative all I need to do is minus x that's it hey pretty simple so pretty simple pretty fast okay it's super simple super fast right then. Okay let's see what else we got and then we can so for example my square root x big square root simply given x x squared right so big square 0 को square 1 को square 2 को square 3 को square and so on right there okay all right so you can do all these so please try them out so we can do all these so your order operations in your setting so order operations कुन पहिला हुने कुन पछि यो सबै preserve हुन्छ x त आफैमा के हो array हो तैपनि all these order of operations are it's all preserved means सबभन्दा पहिला के हुनु यो हैन 0.5 times x पहिला यो चाहिँ हुन्छ हैन पहिला चाहिँ यो अपरेसन हुन्छ हैन त्यसपछि यो जोडिन्छ सेकेन्डमा हैन थर्डमा चाहिँ के हुन्छ भन्दाखेरि थर्डमा नेगेटिभ भएर हैन किन आइदर नेगेटिभ भएर अनि त्यसको चाहिँ to the power 3 right okay so likewise so it all works out okay so you don't have to worry about anything I mean it just takes care of all the things right? So those are low level details, and worry you can think at a higher level. Okay, okay, same. So just say हामीले त्यहाँ माथि प्लस गरेर x + 3 गरेँ नि मैले गर्दाखेरि एक्चुअली कल हुने हुन्छ यो हो है यसरी कल हुन्छ यो चाहिँ सिन्ट्याक्टिक सुगर हो सिन्ट्याक्टिक सुगर हाम्रो लागि सजिलो प्रोग्रामरलाई सजिलो है त्यो हरेकचोटि np.add तर इन्टरनली के हुन्छ भन्दाखेरि तपाईँको यसलाई यो भनेको चाहिँ अनि यो कल हुन्छ कि np.add कल हुन्छ है यसमा मैले x + 3 गरेँ गर्दाखेरि त्यस्तै गरी the same thing I can do np.add x and 3 x and 3 see, you see the same thing right? You have as programmers as humans we like this better right? Because this is what we're used to this right? Rather than you internally it's a unique call this has been written by someone right? You let's say highly optimized optimizing this so telling your function they take care of all of this right? Okay, so likewise with all something just power modulus and so all of these can be the same multiply the same thing right? Multiply so same thing we can write it this way. Let's see what is that here. So it gives you the same result right now. Okay. All right. So so that's how your funcs make things really simple, really fast. Right? So always use your func in vectorized operations in general. Right? No loops. Okay. All right, so just as NumPy understands Python's built-in arithmetic operation, okay, it's the absolute value functions, or even it can even recognize Python's built-in absolute value functions. Okay? ABS and absolute because the Python is the NumPy winner. Okay, so ABS, similarly ABS, rather okay, let's x is equal to np.add. So let's put some negative values as well. Let's see, 1, 2. Minus some. Let's introduce some negatives as well. So yeah, x of a melee ABS and simply ABS x. Okay? It gives me the absolute value. Absolute means what is absolute value? Absolute value. Absolute value. That's enough. It's -3 absolute value. What the 3. Anyways, this magnitude method, right? This absolute means it gives you the magnitude. Right? With your sign design, so it just gives you that quantity, the magnitude, right? Magnitude method. Right? Okay, so this is -5 to 5 0 to 0 -3 to 3 right? So it's although ABS is not NumPy function right? You see core Python, but still it recognizes that, right? NumPy recognizes, right? Or you can of course use np.absolute equivalent. Right? You can use that one as well as the same thing. Right? Okay, so you can use ABS, which is LESO short form, or absolute ABS is the same. Okay. All right, so likewise, we can do these complex things, complex numbers. Let's see how much time we do. 4 minutes. So in the meantime, so I go attendance. So